Okay, let's continue with our sum difference identities now with sine. If I have the sine of a plus or minus b, the formula that we're going to have for that is that I'm going to have the sine of a times the cosine of b plus or minus the cosine of a times the sine of b. Okay, so if we do an example like the sine of 30 plus 60, then I'd be saying the sine 30 times the cosine of 60. Since this is plus, now we use the same sign here. Then I'd choose the cosine of 30 times the sine of 60. And when I do that, the sine of 30 is 1/2. The cosine of 60 is equal to 1/2. The cosine of 30 is square root of 3 over 2, and the sine of 60 is square root of 3 over 2. If I add those together, 1/4 plus square root of 3 times square root of 3 is going to give me 3/4. I get 1. The sine of 90 degrees is 1. Okay? So this works, and again, I could do an example where we had minus. Actually, let me give you one that you probably otherwise would not know. Suppose I wanted to know what the sine of 15 degrees was. What's the sine of 15 degrees? And you say, oh, I just put that in my calculator. Well, no. You need to be able to figure this out without a calculator. So I would want to set that up as the sine of 45 minus 30, because those are two values that I currently know. And so using the formula I have there, I would say this is equal to the sine of 45 times the cosine of 30. Since this is a minus, I'm going to choose the minus there, and then say the cosine of 45 and the sine of 30. So here I get square root of 2 over 2. Here I get square root of 3 over 2. Cosine of 45 is square root of 2 over 2. Sine of 30 is 1/2. So I would end up with square root of 6 over 4 minus the square root of 2 over 4. Which, if I write it as one fraction, would be the square root of 6 minus the square root of 2 all over 4. If you were to put that into a calculator and find the decimal equivalent, it would be the same thing as the sine of 15 degrees. Sorry, it looks like I cut it off a little bit at the bottom. So square root of 6 minus square root of 2 over 4 is going to give me the same value that I would have as what I just had for the sine of 15 degrees.